Okay, pressure and density are totally related to each other, and they use the equation pressure equals rho g h. Okay, so rho is kilograms per cubic meter, g is meters per second squared times your height. Okay, so kilograms meters per second squared, remember that's newtons, okay, and your height is actually in meters. So do you see how that works out to newtons per square meter? All right, so your kilograms meters per second squared, rho times g is density times the acceleration due to gravity. That's called weight density. Okay, pressure and density are totally related to each other, and they use the equation pressure equals rho g h. Okay, so rho is kilograms per cubic meter, g is meters per second squared times your height. Okay, so kilograms meters per second squared, remember that's newtons, okay, and your height is actually in meters. So do you see how that works out to newtons per square meter? All right, so your kilograms meters per second squared, rho times g is density times the acceleration due to gravity. That's called weight density. Okay, so let's look at that weight density idea. Weight density is basically, instead of being mass over volume, it's weight over volume. Okay, so your density is your kilograms per cubic meter, and then when you multiply that by 9.8, do you see how your kilograms times 9.8 gives you your weight? So that gives you your force per cubic meter. Okay, and then when we multiply that times our height, we end up with force per square meters, which is our pascals. So weight density is sometimes kind of a handy term, but it's related to the height of the column. The pressure at the bottom here is related to the density of this material. The density of this material now has mass, and if it has mass, it has weight. And then if we take that and we multiply by the height of the column, then we end up with our pressure down here at the very bottom. Now, it doesn't really matter if it's a big thing or if it's a little thing, because yes, you have less weight, but you also have a smaller area. So proportionally, it comes out the same. So it doesn't matter if we're talking about a big lake or if we're talking about a cup of water. If we're just 10 centimeters down in both, we have the same pressure, because it has to do with how deep we are. Okay, here's a question from your study guide. Determine the absolute pressure at the bottom of the lake that is 3.6 meters deep. So here's our lake. It's 3.6 meters deep, 36 meters deep. Okay. One of the things we need to remember is that there's pressure up here also. The air itself is exerting pressure. So remember that the air pressure, normal air pressure, is 101,000 pascals. Okay, so to solve this, we're going to go pressure equals rho g h. Pressure equals, okay, it's water. We're in a lake, it's water, so it's 1,000 times 9.8 times our depth, 36 meters. So that's going to give us big number, 352 800 pascals. Okay, so that's a little bigger than we were getting with our book sitting on the table. Okay, that's just from the water. Then we need to add in the 101 pascals from the air, and that's how we get the 453,000 pascals that they give us for our answer. Okay, so see, that's not too bad. There's another problem in your guide where you're hooked up to an IV and there's blood coming in the IV. Probably ought to make that red, huh? So there's blood in the IV. And they give you basically the height of the IV column.
It's called plasma.
And so what they want to know is what's the difference in pressure from the top to the bottom. So now we don't need to include the air, so we're just going to use the pressure at the top is basically 0. So we're going to use pressure equals rho g h. See how easy this is? And we're going to use whatever height they give us for the wire across. And then we're going to use the density of the blood, and they also give that in the problem. So see, not so hard. And if you're ever confused as to which equation is pressure, you can always work out the units, and you should end up with newtons per square meter. Okay? So if you end up with newtons per square meter, you probably did it right. I'll see you later. There's 2 more to go. All right, bye.